Hey guys, all right, so today we're looking at lesson 13 in your math workbooks where we're going to be interpreting points on a coordinate plane. So previously we've plotted some points, we've looked at which quadrants they're in, and you've even created some graphs of your own. Now we're looking at something where there's already points given to us, and it's our job to figure out both where those are and then what they mean based on some other information we're going to get. So our first job here is to label each point on the coordinate plane with the appropriate letter and ordered pair. Well, that's referring to down below the grid when it says the letter and ordered pair. We've got A, B, C, and D down here. And I'm going to use my drawing tools so that I can show you where we're at here. So point A is at 7, negative 5.5. So remember that first number in the ordered pair. The first number tells us horizontal. So side to side, it's our x-coordinate. So 7 is a positive number. So if I start at the origin and go to 7, that'd be on the right side of the number line. But then I need to use that second coordinate, the negative 5.5, which the second coordinate in the ordered pair is our vertical number, our up and down on the y-axis. So negative, I'm going to go down below the line. I only see one dot down here, so if I check it, sure enough, it's between negative 5 and negative 6, so it would be at 5.5 because 5.5 is in between 5 and 6. So this point right here would be known as point A, and it tells us to write the letter and the ordered pair. So I'm going to go ahead and copy that 7 and negative 5.5 near that. Then we've got another one that we're going to use. So I'm going to switch colors here to try and keep it easy to follow. So point B is going to be located at negative 8, 4. Negative 8 is the horizontal quadrant, so I'm going to go start at the origin and go back to negative 8. And then positive 4 is our second one. So I'm going to go up in the positive direction 4. So right here would be point B located at negative 8, comma 4. We're going to do that same thing with the other 2 points that we are given. So we've got C located at 3, 2. So positive 3, so I start at the origin, positive 3, positive 2, and sure enough, point C is right there. And finally, now this last one has a bunch of decimals in it that doesn't need to be tricky, though. We just need to put our logical brain on and think about what this is asking us here. So our first coordinate, negative 3.5, horizontal, side to side is the first coordinate, so it's in the negative direction. I'm going to go to the left. 3.5 would be in between 3 and 4. And then the second coordinate is 0.2. There's no minus sign on it, so it's a positive number. Well, if we think 0.5 is halfway, 0.2 is going to be closer to 0. It's going to be less than halfway. So this little dot right above the axis line would be our D. Makes sense. It's just above because it's only 0.2 or 2/10 of the way. And that again is located at the coordinates that they already gave us. So it's just a matter of copying those down. All right, so we've identified some of the points that they plotted. Now we're going to go to part 2, where the graph shows the balance in a bank account over a period of 14 days. This axis is labeled B and it represents the account balance in dollars. The axis labeled D represents the day. So they've renamed our X and Y axes with B and D because we're utilizing this in like a real world situation. So I'm going to do a couple highlight things with this just to make sure we know what's what. So where we see the letter B there, they're using that B represents the balance. So these are all dollar amounts. Ooh, that's awfully fat to make a dollar sign. And then along the other direction, maybe I'll make that a little bit thinner. So D here is looking at the day. So this is day 1, day 2, day 3, and so on across that horizontal axis here. So recognizing which is going to be super helpful. When we go to estimate the greatest account balance and then tell on which day did it occur. Okay, I'm going to make it so I can hopefully type my answer here. I got to get out of my drawing tool, sorry. Just click here, and then I got to scroll. If you hear that knocking sound, it's the wind blowing stuff around on my door. All right, so let's try this again without the drawing tool. So estimate the greatest account balance. Okay, greatest, largest, and we're talking about the balance. We're talking about the money, the B. So we're looking for the point that is highest or greatest on that vertical. And if I look, I see these 3 points here are up pretty high, but actually this last dot is up even just a little bit higher. So I'm going to be looking at that dot to answer this question for my greatest balance. Now it says to estimate it. That dot is in between 350 and 400. If I look at the numbers on that axis line, it's in between those two. So in between 350 and 400, I'm going to say 375. And that falls on day 14. So it matches up with the 14 there. So since it asks for both the balance and estimate of it at least, so somewhat close, and which day, I'm going to answer that on day 14, the balance was about, and it's a balance, so a dollar amount, I'm going to use a dollar sign, and we said 375. So that'd be my answer to question number 1 there. Then we're asked to estimate the least account balance and on which day. So again, same question, we need a dollar amount and a day, but now we're looking for the least, so I'm going to look for the lowest point. Now, we've got these 2 points which are low, but we actually have a couple things down here in the negative as well. So the one that's actually the least is way down here below that axis line, and it falls below the 11th day. So I'm going to start by saying on day 11, the balance was about, well, it's negative. So if this line was 0, there's negative 50, there's negative 100. That dot is almost to the negative 100. So I'm going to say this is at about negative 90. Now we're talking about a bank account. So while going negative is not a good thing, it is a possible thing. So we do always have to kind of just be aware. Can we use negatives? Does it make sense to have negatives? And in this case, it does. So what does the point 6 negative 50 tell us? Back that up a little bit. All right, 6 negative 50. Well, if I was to plot that point on the line, I'm going to go up here and think, okay, 6 horizontal always goes first, so I'd go over to the 6, and then negative 50 would be down, and there's actually already a dot there. Okay, so we went to 6 on the horizontal, which is our days, our D. So the 6 represents that on day 6, and the negative 50, well, that's our vertical, which is our dollars. So negative 50 is the amount in the account. So on day 6, there was negative $50 in the account. Whoever this is needs to be a lot more careful with their money. And then we're asked, how can we interpret? We've got those symbols, so the absolute value, that's what those 2 straight lines mean, remember from a couple lessons ago. The absolute value of negative 50 in this context. Well, this context, 50, we don't have any numbers near that size on the horizontal axis. So negative 50, where we do see that, is on the vertical axis, on the dollar amount, the balance. But the fact that it's in that absolute value sign is how far from 0 are we? It's a distance from 0. So we can interpret that we are $50 away from 0. And in this point, 0 would be just a level bank account, an empty, brand new bank account. So we are $50 from our start starting point or an empty bank account. There we go. Okay, we've got a couple more questions. Oh no, I take that back. That's the last one for this. So we're finished with our bank accounts. We're going to look at one last scenario that goes along with our grid. So here we've got one that's got high and low temperatures, and you'll notice we've got two different colors of points on here. So coordinate plane shows the high and low temperatures in Nome, Alaska. That's a real place. Over a period of 8 days. The axis labeled with a T represents temperature in degrees Fahrenheit. Fahrenheit is what we typically use. So if you watch the Weather Channel, that would be our normal degrees that we see. And then the axis represented or labeled D represents the day. So I am going to just kind of highlight those two key features there again, because I think it's important we know what's what. So our T, so this whole row here is the temperature, whereas the D is the day. So along this way, we're getting our days. Now, what was the warmest high temperature? All right, I got to get out of the drawing thing again. And get back to where we were. There it is. And stop. All right. The warmest high temperature. Now, this actually didn't tell us anything about what red versus blue means. But I'll bet if we look at it closely, we can figure it out. Because if I look at day 1 and I go up, there's 2 dots here. Well, 2 different temperatures on the same day. One's red, which typically represents warmth. One's blue, typically cold. So I'm going to bet that we've got the high temperature and the low temperature represented by red versus blue. So we want the warmest high temperature. So we're looking at the highest red dot, the warm one. And it looks to me like that very first dot here is the highest one, the warmest one. And that dot is on day 1, but the question doesn't ask what day. It asks what was the temperature, which was 28. Ooh, that's not very warm. So what was the warmest high temperature? 28 degrees and degrees Fahrenheit. If I want to make a full sentence, I could say was the warmest temperature. Now we're asked to write an inequality, that's those mouth symbol things, to describe the high temperature H over the 8-day period. All right, this sounds tricky. It really doesn't have to be, though. Luckily, I've got this nifty little ink to math thing where it actually reads my handwriting. Okay, so I want to be able to see the question and my graph. So an inequality with H. So instead of using an X, we're going to use an H. So I'm going to start by writing an H there. And the high temperatures. All right, well, the highest high temperature that we saw was the one we just noticed, which was up here at 28 degrees. So the temperature was always less than or equal to 28. That's going to be our first inequality that goes with that. However, I'm going to go ahead and insert that, and I'm going to make one more inequality as well, because while it is less than or equal to 28, we don't have any high temperatures down here in the negative. So we also need kind of like a bottom point on this. So I'm going to use a second inequality to show that we have a range. So we're within a span here, but we have kind of a top cap and a bottom cap to that range. So I'm going to draw one more time using that math thingy. And notice that while the high is less than or equal to 28 degrees, it is also greater than or equal to our lowest high temperature, where the lowest red dot I see is right here at 2. So I would also add a second inequality that says that the high is greater than or equal to 2 degrees Fahrenheit. Then we're going to go to what was the coldest low temperature. All right, the lows are the blues, the coldest. Okay, well, like a thermometer, we get colder as we go downward. And I see the lowest blue dot down here, which looks to be in between -2 and -4. Well, in between 2 and 4 is 3, so in between -2 and -4 would have to be -3. So -3 degrees Fahrenheit is our coldest low temperature. There we go. And again, we need to write an inequality that describes this. So we're going to do one more inequality here. Go back to my little math doohickey. And we just said that, nope, oh, let me clear that. This time we're using L to represent low temperatures. We're not using H anymore, so I need to use L instead. Since -3 was the very lowest one, the low temperature was always greater than or equal to -3. Remember that symbol wants the biggest thing, so it opens towards what's greater, which is why we would say that as L is greater than or equal to -3. And again, we could use a second one to say that it does cap off, at least within the range that we've got here of days 1 through 8, where the highest of the low temperatures was at 26. So we could make it a double like we did here as well. It says an inequality, a single inequality. So I think we're fine with just what we've got there. We could always go above and beyond though. And on which days, so possibly plural, did the largest difference between the high and low temperatures occur? Okay, difference, high and low. So if I look here, the high and the low temperature are really close together on day 1. There's only a difference of 2 degrees from 28 to 26. So I don't think it's going to be on day 1. Here it looks like there's a bigger gap. Here it looks like it's an even bigger gap. So if I look, I'm thinking it might be day 3 here. Let's see, what's the gap between these? That one looks to be at 11. That looks to be at 21, so that would have a 10-degree difference. So possibly day 3. But as I look, I see a couple others that look pretty big. This one looks pretty big of a gap to me too. 17 and 7. Oh, we've got another 10-degree gap here. Let me do a little highlight. Draw. Doesn't want to let me highlight right now. Okay, I'm not going to mess with it. And finally, we've got another one that looks like a pretty big gap right here, where this one's at 7, this one's at -3. Well, -3, -2, -1, and 0. That'd be 3. And then going up 7, once again, that's actually another 10-degree gap between our high-low. That's a difference of 10. So there's, from the axis line up is 7, from the axis line down is 3. 3 and 7 together is 10. So that's why this question asked us, it's why it had that little S in parentheses, because it knew we were probably going to have more than one correct answer there. I'm trying to back this up so I've got some space. And what is the difference? All right, so we saw the biggest difference on days, what was it, 3 and 6 and 7. So days 3, 6, and 7 all had a difference of 10 degrees between the high and low temperatures. In other words, between between that red dot and that blue dot that were on the same day. And we've got one final question here. Okay, which days? Write down this difference. All right, we finished that question. And finally, on which days did the smallest difference? Okay, so just the reverse of what we just did. Now we're looking for the points that are closest together within a single day, so on a same vertical line. So day 1 is super close together. There's only a 2-degree gap. I'm going to check 2, 3, 4. Oh, what's this one? From 10 to 13. Okay, that one's close, but that's a 3-degree gap, and this one was only 2. Here's another close one, but that one again, it's below the line 1 degree, so this one's again going to be 3. So there's only one that has a 2-degree gap. So day 1 oh, we don't want a new question. There we go. Day 1 has the smallest difference, in other words, the gap between them, the space between, with only 2 degrees of change from low to high temps. All right, that takes care of this lesson. Hopefully it was helpful. Always reach out to us. If you need anything else, Mr. Morgan covers the practice problems too. If you want to watch that video, there's answer keys linked, and we have math help available Monday through Friday, so you can reach out to any of us math teachers. Hope to see you soon. Bye.